Hello all and welcome back. So in this video, let us continue our discussion on queues and now let's learn about different types of queues which are available. Now the understanding is same that we have to first make sure that we understand the simplest queue a lot more in depth, which I believe we have done by seeing all its operation, implementing it in various ways, as well as till now we have done some questions as well on the same, right? Now, there are some overall variations of queues which we should be aware about because many times what happen is that in a particular question or any real life use case, we have to use one of those variations. So let us see them one by one. The very first one is actually the simple queue, which we have been studying till now. Simple queue. In this, we are aware that how we have a queue like this. In this queue, we have a front and we have a rear. As well as we can just enter things from here and they can just go out from here, right? So we have a one entry and one exit and it follows our LIFO principle. LIFO principle. So maybe we can write it down, one entry, second, yeah. So it has a single entry and single exit, right? We have seen this a lot in depth, single entry and single exit. Great. So this is how we can have a normal queue. We have implemented the same. Any new element which is added, it will always be added from a single site, right? So now let us move forward and learn about one more queue, which is your circular queue. Circular queue. So much like the overall circular linked list, here also the idea is that overall my queue is going to be circular. So we can have an example of this to better understand it. Weeks in a days in a week, right? That's a very good example where circular queue can be used. So if we have something like this, if we see this, this is actually a circular queue where we have these elements. Okay, so Sunday, then Monday, Tuesday, Wednesday, Thursday, Friday, then Saturday, and then it starts again. Okay, so all over it's just a queue where items are one after the another, but the end or the rear are connected, right? So here we can take any insertion, anything as front as such, and we can basically include any new element there, right? So let us understand a little bit more on this. Let me write it. First node is connected, or rather I should write last node is connected to my first node, right? So last node is connected to my first node. Here as well, we will have to make sure that we are seeing from where we are starting. So let's say if you start from Sunday, you have to remember that, right? And once you are able to then move forward and you encounter Sunday again, then is when you can say that you had a full round of your queue. It is also known as ring buffer, just a terminology, okay? Because things are connected to one end to other end, just like a ring. Okay, insertion of course will take place at the front of the queue and deletion at the end of the queue. Great everyone. So I hope that is clear as well. Pretty straightforward. Now let us see the next variation. Moving to the next variation, we have something which is known as a priority queue. Now to think about priority queue, you can just take a real world example. Let's say you are going in a restaurant and there already reservations are there. So it is not working in a first come first serve basis, but rather each and every element has some priority attached to it. So what I'm effectively saying is, let's say these are few elements overall. Let me draw it nicely. So let's say these are your elements in a queue. What exactly happening is that if I have, let's say, 5 elements, whereas in a generic queue, it opens from the right and you can enter from the left. Here we have a priority attached. So let's say this is having 5 priority, this is having some 10 priority, this is 2, this is 1, and say this is some 7. Okay. Now, if you have done the reservation already, okay, if you have done the reservation, then it doesn't make sense to actually treat people on first come first serve basis, right? In a similar manner, in many lines, we gave a little priority, right? We gave priority to old age or sick people, right? So that thing is of course also there, everyone, where we are giving priority to them, the old age or the sick people. So the understanding is the same based on the priority, right? Let me write that as well. Elements are served or popped based on the priority. Now, of course, there is a different way we in the backend or implement this queue, but the understanding the working is like this based on the priority. Okay, so that is where actually it will be used. Now we will be using the same in many let's say algorithms. So we'll try to read about this as well. It's a priority queue, which is a different topic altogether. Okay, great. So now let us move forward, everyone, and let us see the last one, which is, let me add a new page. So the last one is a DQ, double-ended queue. Double-ended queue, which transforms to DEQ. Okay. So what happens in double-ended queue again? The understanding is that let's say we have a line in a restaurant. Okay. And what is allowed is that just it happens where if you are starting in the very start, if you are standing in the very starting, then people can actually enter from this side as well. So anyone can enter from this side. So this is in and this is out as well. Okay, so this is out as well. At the same time, this is in and this is out as well. So it's a double ended, right? You can enter and exit from any side. So what happens here again? Because it is double ended, we can have a case where one can enter and exit from both the sides. Okay, so if let's say someone joined the queue late, he can maybe just exit from here only. And from the starting also, we can import our elements. We can include any element or any node, right? So that is what a double-ended queue or DQ is. Now, what happens in Python? We have a collections class. So from collections, we actually get this DQ, which is a type which we can actually use. So let's say if I use DQ, it is having append left. So what happens by default, it is saying that appending is happening here, just like in a normal queue, but it has append left as well. Similarly, we have pop and pop left. Okay, so these are all the methods. Actually, it does support extend left, then insert as well, where you can insert at any index. Okay, so it is asking you for a I as well. But overall, the basic understanding is that it's a double-ended queue where you can insert or actually just get out from any of the sides, and we have the append left and pop left function for the same. Okay, so I hope each and every one of you is now understood what exactly is the case. In this case, rear will actually be some function, right? So we saw that how rear, this end is known as rear and this is front, right? So both of them you can see actually. So that is the overall idea behind this. In many places, this type of queue is also used where you can include or insert anything from both the sides, right? But majorly it's a variation of a single queue only where we are allowing elements to leave from both the sides and enter from both the sides as well. Okay, all. So I hope this was clear. Now we will be having some questions where this concept will be used, but majorly the basic queue is the one which we need to majorly master because majority of the times that is what is used as well as that is what will be asked to you in questions. Okay, and the same which we will be using in BFS and others. So don't get a lot confused in the implementation. They are just the variations. Okay, if it is required, of course, we can implement them from scratch as well. But then again, there can be n variations for anything. We should just be aware of the basics clearly, and then implementing them will not be a problem. Okay, everyone. So I hope with that this is clear. So now you will be given some questions of queues, and I want all of you to make sure that you are applying the basics right and are able to solve those questions. Of course, hints and all the solutions will be provided to you as well. Okay, so thank you, everyone.